So in this video we're going to be given 2 points that a line goes through, and we're going to calculate the slope of that line through those 2 points. And this is a formula that you may want to write down somewhere on the worksheet, and when we get the homework on Monday, that practice, you'll probably want to write that down again. So the slope of this line through these 2 points, we're going to subtract the 2 y coordinates on top and the x coordinates on the bottom. And in any ordered pair, the y coordinate comes second. So the 2 y coordinates in this pair are 0 and -2. Now, they are in order. Order does matter, but it really doesn't. And this is what I mean when we do this. So the 2 y coordinates are 0 and -2. So in this first case, we're going to take 0 minus -2. Okay? Those are the 2 y coordinates. Now, on the bottom, we're going to subtract the 2 x coordinates. So the 2 x coordinates are -1 and 3. So on the bottom, we're going to subtract -1 and 3. Now, the important thing is this, is that if we start with the 0 on top, we need to start with its partner, or the -1, in the denominator. So we need to take -1 minus 3 in the denominator. So when we calculate this slope, 0 minus -2, well, that becomes 0 plus +2. So we're going to have 2 on top, -1 minus 3 is -4 on the bottom, and then you do any simplifying you can do, which in this case is -1/2. So the slope of the line through those 2 points is -1/2. Now, just below that, and just to prove that order doesn't matter, just below that I'm going to find the slope. And on top, I'm still going to subtract the y coordinates, but instead of taking 0 minus -2, I'm going to take -2 minus 0 on the top. And then what's going to happen is then on the bottom, since I started with -2 on the top, I need to start with its partner, or 3 in the denominator. I'm going to take 3 minus -1 in the denominator. Okay, so one way to look at it is that the numbers that are above each other in this, when you set this up, should come from the same ordered pair. So for example, here the 0 and the -1 come from that same ordered pair. The -2 and the 3 come from the same ordered pair. So you really need to be careful of that. And just to show it doesn't matter if we do it this way, -2 minus 0 becomes -2. And 3 minus -1, well, that becomes 3 plus +1, which is 4. And -2 over 4 again reduces to -1/2. We get the same answer either way. So doesn't matter with which one you start with. You just have to be careful that if you start with one on the top, you got to start with its partner in the denominator. So in the second one, in B, the slope so our 2 y coordinates are the 3 and the -1, so that's what we're going to subtract on top. So I have 3 minus -1 on top, and then in the denominator we're going to subtract the 2 x coordinates. Since I started with 3 on top, I got to start with its partner, or the 1 in the bottom, and then -4. So in this case, 3 minus -1 becomes 3 plus +1, or 4. 1 minus 4 in the denominator is -3. So our slope is -4/3. Now, just to prove a point, if we did it in the opposite order, where the slope is equal to, instead of 3 minus -1 on top, let's take -1 minus 3 on the top, over. Now, since we start with -1 on top, we need to start with its partner, or 4 in the denominator, minus 1. So on top we've got -4, denominator 3, which is -4/3. So we get the same answer either way. Now, in the next one, there we go. On the next page, we've got a couple of special cases here. Okay, so if we find the slope between these two, the slope is equal to, so we're going to subtract the y coordinates on top. Again, the order doesn't matter. So we've got -3 minus 2. And then in the denominator, I'm going to start with the partner of -3 then, 4 minus 4. Those are the two x coordinates. So when we subtract these on top, -3 minus 2 is -5. And then in the denominator, 4 minus 4 is 0. Now, if you ever try to divide anything by 0, you're going to get an undefined answer. So we say that slope doesn't exist, or it is undefined. Now, this is a special kind of line. If we take a quick look at where these points are on the coordinate plane, sketching a quick graph, the point 4, -3 will go to 4, -3, there's that point. And the point 4, 2 will be up here. And if we connect those and draw a line, what kind of line do we have? We have a vertical line. So all vertical lines have an undefined slope. Why? Because there is no change in x. In a vertical line, this x coordinate is the same as this x coordinate, which is the same as this x coordinate, which is the same as this x coordinate, which is the same as this x coordinate, and so on and so on and so forth. So there is no change in x. So we'd always have 0 in the denominator, which means that that slope does not exist. Now, the other special type of line, if we find the slope in D, so if we subtract the two y coordinates on top, we've got -3 minus -3, and then in the denominator, since we started with this -3, or did I start with this negative? Anyway, so I started with this -3 on the top, so I'm going to start with the -1, or its partner in the bottom, and then -5. So -3 minus -3 becomes -3 plus 3, which is 0. -1 minus 5 is -6, and 0 divided by anything is always equal to 0. So the slope of this line is 0. Well, if we take a quick look, when we plot these points, and if we take a quick look at what kind of line this is, the point -1, -3 is here. The point 5, -3 is here. And if we connect those, we have a horizontal line. So the slope of every horizontal line is in fact 0. Why? Because there's no change in y. The y is same here as it is here, as it is here, as it is here, as it is here, and so on. Okay? So the slope of every vertical line is undefined, while the slope of a horizontal line is 0. So that's quick brush up. I hope it was kind of a review on the slope formula and so on. And Monday in class we will have plenty of practice finding the slopes and rates of change of different situations.